So the next topic for us is called linked list, right?
Mhm.
The, so what is a linked list? It's a sequence of elements, right? You have sequence of element where the previous node has the address of next node. So see,
Mm.
so far what we have seen, like if we talk about list, tuple, sets, for example, okay, they're all continuous. We call them contiguous, right? They are all together in the same memory location. Okay,
Mhm.
but in linked list, the elements can be at different memory location, but the previous memory location has the address of the next one. So that's how you have those elements connected, right? So
Mhm.
we call them as sequence of data elements, right? Okay, now we do not have a standard library as of I know, okay, for linked list, okay.
Mhm.
Instead, we can create our own linked list. So we'll create a class called node, okay, and then this node will have two things, right? If you look at linked list, I'm sure have you done it in C, C++ somewhere? No, right?
I've done in Java, sir. Linked list,
No,
yeah.
you have done in Java, right?
Yes, sir.
Okay, then good. Then you understand that each node has two parts, right? If I can show it in Paint. So each node, okay, this is called node, and this
Mhm.
node has two parts, right? One is the data,
Mhm.
right? And second has the address pointer to the next node. And next node can be somewhere else here, right? This will also have, okay, two parts. And this node will have the address of this one. Okay, and similarly, that's why it's called linked lists. Okay, so you have lists which are linked to each other. So we'll create a class, okay, and it'll have two members, the data and the link to the next node. And
Yeah.
now when you create the first list, okay, or first node rather, uh, what will be the default link?
The previous one.
No. So previous one, that is double linked list, we call them.
Oh.
Double linked list will have like, you have two nodes. Okay, I mean three, each node has three parts. Okay, you have value and to the previous node link and next to the next node link. Here in single linked list generally means singly linked list. In
Mhm.
singly linked list, you don't have connection to the previous one. It's always to the next.
Okay.
So when you create an empty node, okay, or first node, not empty node, first node, it will not have any link. So that means it will point to null. So that's how you know that you have reached the last element. So if the if the next node value is null, that means you have reached to the last node. Okay. So
Okay.
let's create a class and we'll call it as node only. Okay. And we will have our init. Okay. So init, oops, not del, sorry. Init will have data. Okay, or value which is for the given node. Okay, and when you create a node, by default it will have no value and no link. We have to link it later manually. Okay.
Mhm.
Okay, so we say here node. Okay, and I'm going to add two members called self dot value, which is equal to data, right? And we
Mhm.
can make this as none. Okay, that means when you don't pass, then take default value as none. Okay, self value, and then we'll say self dot uh, next node, something like that. Okay, next node equal to none. Okay, so when you create it, it's all blank. Okay, now we'll create one more node, okay, which we call it as pointer. Okay, this
Mhm.
will help us to move along the path. So node is, you're creating each node and they are somewhere in the memories. And then you need a pointer which will simply move around. So because I told you, right, what we do in data structure, we need to traverse, right? I need to know what is the first element, what is the last element, which is the mid element, right? So you need something that will move around,
Mm-hmm.
correct? So that is called as, let's say, I call this as class, okay, traverse list or something, or list pointer, something like that. Let's say I call it as list pointer, okay, and here again we will define the init, and I will call it as okay. Anyway, this doesn't need any value, so we'll have self dot, we call it as head, okay, self dot head. We call this as head, okay,
Mm-hmm.
and initially it is pointing to null. Okay, so we have everything that we need. Now let's start building it. So I'm going to say if name equal to main, right? If
Like a
name,
main function?
sorry.
Is this like a main function or something?
Aha. So see, we are writing main function, and every module will have a main function, right? Whatever you write from beginning, it's a main function.
Yeah.
Now, when you are using that file, okay, now let's say, okay, for a minute, let's say I give print hello, let's say. Okay, now this is June 2023, right? If you run, you get this class and you get print hello because we are calling this. Now let's say in P11, I say import June 23. If I say import June 23, what it does, it imports those classes, those two classes that we have, and it executes this main program. You see, you get hello here, but we don't want to print this hello, right? We are interested in class. Whatever you are doing here, it's personal matter of June 23, right?
Yeah.
P11 should not have access to it because P11 is calling June 23 because it needs these two classes. That's all. Whether you have classes or functions. Okay, so to hide this from being called by other files, to
Mm-hmm.
hide these lines being called by other classes, you put them as name equal to main. It means the name of the calling file, if it is this file. So when I say June 2023, then the name is main. That means because this file is main file,
Mm-hmm.
it calls print hello. But now if I call from here, okay, so main is P11, not June 2023, because I'm calling from P11.
Okay, so
So
main is
this
only
condition
for
becomes false.
main is only for that specific
File.
file. Yeah, file.
File, yes. Okay, so yes, so that's why, okay, anything that you want people to have access to, you will put it here. And what you don't have, if you don't want people to have access, you put them in main. It means that only if this file is called, the content here will be called. If somebody else is calling it, this becomes false. Name equal becomes false.
Hmm.
Okay. Okay. So, okay, so name is main here. Now I can go and write my own logic to implement this linked list here. So let's say I call um, list one, okay, and I'll call this list one instead of list one. Let me call as header or something. Okay, header equal to the list pointer. Okay, done. Header is list pointer. Now we will call this header dot value. Okay, so header is a list. Sorry, it's a class
Yeah.
which has head value, right?
Mm-hmm.
Now I will call this header dot head. Okay. Instead, I think header dot head doesn't look good. Let me call it as list.
Okay.
Okay. List dot then list dot head. Okay, so I've created a list, okay, which is pointing to this header, and now I'm saying list.header should point to a new class or new
Mhm.
list. This is your actual node. Okay,
Mhm.
node. Okay, and node, we can give the value for the data. Okay, here, let's say value, will make it as January. Let's say we create month name. Okay, so now we have created two objects. One object is the header object.
Yeah.
Okay, second object is the class, the linked list class.
Mhm.
And the first object's value is pointing to the next, to the actual linked list, right? So we have linked list with one node only, which has
Yeah.
a value of,
January.
yes. Okay. Now we will create the second node. Now to create second node, let's say we call it as N2. This is equal to node, right? And now this will have value. Let's say we put February. Okay. Now you see, now we have second node created. The first node pointer should point to this node, isn't it?
Mhm. Yeah.
Okay. So first node pointer is what? First node is represented as list.head.
Mhm. Tail.
List.head dot next node.
Oh,
Correct? See,
yeah.
don't don't think of dot as something. Okay, you assume this is one single variable, one single object.
Mhm.
List.head is one single object. So
Mhm.
this object dot next node, right?
Yeah.
Now this has to be equal to our N2. Okay, so far what we have done, we created a node, we assigned to a header. Now we created second node and we have linked the second node to the first node.
Mhm.
Pointer is still at the first node, January. But now
Yeah.
January node is linked to February.
Mm.
Okay, now you can, you can have next node created. Let's say I create N3 equal to node of March, let's say.
Mhm.
Now N2 is pointing, N2 is your second node. The second node has to point to the first node. So N2 dot next, next node, right? Equal to N3, right? So
Yeah.
here we created header. We created first node with value Jan and pointing to null,
Mm.
correct? Because by default it is none here.
Yeah.
Now we are creating second node with value February and pointing to null. Now here your this is the first node. First node is now linked to second node. Similarly, here we created our third node. We created third node with value March and pointing to null. Here, okay, second node is now linked to third node. So this is how you create linked list. So we have created a linked list, right? Now,
What is
how do we move through this? Okay, so I told you linked list. Sorry, any data structure, we should be able to move right wherever we want to, isn't
yeah.
it? Okay, so tell me. You had a question?
No, no. Yeah, I was like asking what if we have to like if we complete a linked list and we want to add something in the middle of
Yes,
the link.
exactly. We'll do that. Okay. So properties of linked list is obviously, if I go here, So properties that we will see: traverse, that is move around,
Mm-hmm.
insert, and delete, right?
Mm-hmm.
So these are the properties that we'll have to add here. Yes. So we just created it and we will see all these three functions. That's the objective of doing that. Okay. So let's create. Okay. So this is all job of pointer. Header is going to take all the responsibility, isn't it? Header is something which is going. So it's like you have a big train. You know, what you see the train, right? That is a good example of linked list. You have train where each bogies are linked to each other, right? And now you have a railway person who's managing this, right? So the railway person is like our list pointer, okay? And is always, it's like an engine driver, always at the first bogie.
Mm-hmm.
And based on the requirement, this fellow will go move around, so come back and forth. Okay, so now I will need to go around each bogie. Now let's say he has to go and search for each bogie. So we'll create a function here, function to traverse through the list, or we call it as linked list, right? List, it is list, but it is linked now. Okay, so
Mm-hmm.
we'll say def traverse. Let's say we use function traverse. Okay, def traverse, and done. Now how do we do that? So to start with, you always reset to the first header. You bring it to the first position.
Yeah.
So I'm going to say, um, mm, let's say point header. I use word header. Header equal to self dot head.
Mm-hmm.
Self dot head. So you are at the first position.
Is there
Now,
is there no indexing for linked list?
no, we are creating our own index.
Mm-hmm.
That's what I said. This is not an inbuilt thing.
Yeah.
Okay, so if it was inbuilt, we would have used, see, when we use list and when we say append, remove, or we use that square bracket for indexing, somebody
Yeah.
has already written that for us, isn't it?
Yeah.
Right? But in linked list they have not, so we have to do that here in class, and here when we use it, it's easy to, it will be easy for us to use, but
Mm-hmm.
somebody has to create it first. So that's what we are creating here. So header equal to self dot head. Now we will iterate through this. So we'll say while this header is not none, right? If it is not none, none means you reach to a point where there is no more node.
Mm-hmm.
Okay, till then you keep moving around. So print, okay, print header dot value. Okay, so I can say something like this. Value in the, or I'll say value from value from the linked list. Okay, now you go here and you say okay, so print value is done. Now the header should go to next one. So header equal to header dot next node. Next node, yeah, it should be next node. Okay, so header equal to header dot next node.
Mm-hmm.
Okay, so this is how you will traverse. Now let's see this. We'll call traverse.
Mm-hmm.
Traversing through the list. So this is going to be list dot traverse, right?
Mm-hmm.
Okay, Now let's run it and see what happens. Oops. Is it pointed? It's pointed to P11, not to June.
Mm.
So see, value
Yeah.
from linked list, right? If you don't want to print, return it.
Yeah.
The best thing is, instead of printing it, you return this. So if you do return, it's going to, this line will not get executed, right? So you'll say val equal to header dot value. And now you say return val.
So I have a question.
Yes.
So when in the traversing function,
Yes.
when you said while can you go up once?
Yeah. I'll just run this and show you. Okay. So January. Yeah.
Mm.
Go ahead.
Yeah, it says while header is not none, right? So like,
Header is not none. Yeah. Yes. Yes.
so when we're traversing, uh, like I don't understand how it traverses while header is not none. Like, okay,
Correct. Okay. So, okay.
first,
Hold on. Yeah. See here. What is that we are pointing header to?
the self dot head.
Self dot head, right? We are pointing to head. Okay. That means first position. Now
Mm-hmm.
here, what is the header value going to? Next node value.
Mm-hmm.
Correct? By
Yeah,
default, what is the next node value?
none.
None, right?
Yeah.
So, okay. So whenever we are creating a node, by default, next node is none. And whenever we are creating a new node, we are saying next node equal to the next node value, N2,
Mm-hmm. Yeah.
correct? So at some point, okay, which is the last element, which is the last node of your linked list, will be pointing to none. For example, when I say N3 here, did we say N3 dot next node equal to something? No.
No.
Then what means, what is the next node of N3?
None.
None.
Okay.
Okay. So when when header reaches N3, that's when this condition will be true. I mean, it not none means what? It will be
The
false.
value. Yeah, yeah.
It becomes false there. That's why it breaks. It will not go inside while. Okay.
Yeah.
Now it depends upon what you want, how you want to project the value. Once you can do simply print, or what we can do is we can create a val equal to list, and you keep adding append, and you keep adding this header value to it.
Mm.
So now what you get, okay, so it goes up, okay, goes down, and when it is done, comes back and returns your val. Now val is what? Val is your list of values. So, it is giving us the list of values that it has read. So these are the values in the node. So again, implementation is how you want to do it for your business, isn't it? I want to print it or I want to read it as a list. You can get it all the values from the list as a list here.
Mm.
But this is the main logic. This is how you will iterate through the linked list.
Okay.
Good.
Yes.
Okay. Now let's talk about adding you want to insert a node, right?
Mm-hmm.
Okay. So insert a node. Okay. So we'll add a logic here to inserting a node to the list, to the linked list. Okay. Now you see, inserting can be done at 3 steps. Okay. Or 3 ways. 3 ways, not 3 steps, 3 ways. It can happen at beginning. That means you are adding in the beginning,
Mm-hmm.
or you are adding in middle, or you're adding at the end. Okay. So how does things change? Okay. I'll again take you to Paint and we'll understand and we'll come back to our program.
Mm-hmm.
So let's say I create 3 lists, 3, okay, January, February, March, right? And we have, okay, we have value, we have address, we have value, and we have address. Okay. Now, what we are saying is your this is header by default. This is our header by default. Okay. And this is connected to this one. This is connected to this one. And this is connected to, generally we represent this as something like this.
Also, the pointer is connected to the next value, not the next pointer, I think.
Next pointer, not value.
Okay.
E2, we said equal to E2, right? We
Okay.
did say E2 dot val or value, correct? When we point to the next node, next class altogether, next, okay? We don't, I mean, next object altogether, not to each value. We did not say E1 dot next pointer equal to E2 dot val. We said E2. E2 is entire object.
Yeah.
That's why I'm not linking to value, I'm linking to the entire list. And this goes to the none, okay? This thing. Now you see here, first condition is adding at the first. So when you create a node here, you have a node, okay? And this is a node, okay? So you create a new node, great. Now this new node has to go to the first. Then what do? It is easy, isn't it? You simply point the node of this to the here. Not much thing to be done. So if you're adding a node in the beginning, simply point that node to the next, I mean, to, you know, the pointer, okay, should point to the head, because by default, your head is here, right? Always head will start from first, right? So that's how you know this is the first. So you point to the head, okay? And now head will become this. This becomes head. This is the logic of adding node in the beginning. Easy, isn't it? Just point it to the existing header, because header will always give you the first list. So point it to the header and make header this one as the header. Okay. If you are adding something, let's say at the back, this is also easy. Why? You go through you'd have to traverse though. You have to traverse till you find the last node, and you break this chain and point it to this. And see, by default, anyway, when you create a node, it will point to the none only, right? So you don't have to do this, right? You simply have to break this and point it here. It is also easier, right? You have to break this none and connect it instead. I mean, if you connect it by default, none is broken. So in this case, what you have to do is when you're adding at the beginning, the new node has to point to the existing node. And when you add at the end, the existing node has to point to the new node. That's the only difference. Otherwise, steps are all same.
Okay.
Okay. Otherwise, steps are all same, isn't it? Okay. It's little tricky when you have to add something in between. Okay. When you're adding something in between, you are, okay, doing two things. One, let's say breaking this link, getting this link here, and taking this link to this two step. Okay. So inserting is not that easy. Inserting, okay, means either you're adding at the beginning, at the end, or in between. Okay. Your step or the logic of doing will change. Okay. Okay. Let's try this. Okay. It might take a little longer, but yeah, it's easy. I mean, it might look complex, right? But if you do step by step, it becomes easy, right? Now, let's say inserting a node at the beginning of the linked list. Okay, so I'm going to create a function called as def insert beginning. Okay, I call it as insert beginning. So when you want to add at the beginning, you say insert beginning. Okay,
Yeah.
and so okay, when you add what do you need to provide? You need to provide the value. That's it, right?
Yeah.
You need to provide the value. Unlike when you are saying insert between, then you also need to provide the the previous one between what, right? So you need
Mhm.
also need to provide the list along with the value. But when
Yeah.
you say beginning or end, you don't have to provide the node. We just have to provide the value here. So I'll
Okay.
say data or something, or new data, let's say.
Mhm.
Okay, great.
Yeah.
Now, new node, okay, that we are going to create is equal to node, and then we are passing here
You did that.
new data. Okay, so
Mm.
now our node is ready, but
Mhm.
it's not linked yet.
Yeah.
Okay, so what we have to say? We have to say new node dot next node
Mhm.
equal to self dot
Head.
header, correct? Self
Yeah.
dot head, right? So
Mhm.
this node is now being linked to the head. Okay,
Yeah.
and your self dot head should now point to this new node, correct?
Mhm.
To new node. That's it.
Yeah.
Okay, so now let's call this. Okay, so I want to add at the beginning. Okay, add at the beginning, and here I'll say new node, right? So let's say um, list is what is pointing dot, what is the function? Insert beginning, and the value, let's say we give December. So I'm giving December at the beginning. So when you traverse, it should be December, January, March, February, March, right? Okay, this is it. Now, if you want to traverse again, traverse again. Okay, you see, you got December in the beginning, right? Simple. New node head should point to the new node pointer should point to the head, and now head becomes your new node.
Yeah.
Okay, inserting at the end. Okay, so inserting at the end is easy. Only thing is you have to do the traversing. You have to go to the last node first. Okay, you have to
Mhm.
traverse to the last node. So I'm going to say here inserting at the end, and you say def insert at end, and then you need new data, right? That's all we need. Perfect. Now, of course, new data equal to new data. And by default, anyway, new data next node is null only. Next node is null anyway, right? So we don't have to do that. But we have to find the last node, and that next node should point to this new node,
Mhm.
right? Now,
Yeah.
so what we do is we check if this is the first node only. Let's say there is no other node. Okay. If there's no other node, obviously this, you don't have to do anything. Okay, so we'll check, okay, if there is no node, okay, in the system. Check if there is existing node or not.
Mm-hmm.
Okay, so I'm going to say if, right,
Mm-hmm.
self dot head is none. That means there is no other node here. If there is no other node, then this node is the main node, first node. We don't have to do anything. So simply we'll say self dot head equal to new node. Done.
Mm-hmm.
And you can stop the check here. Done. Return. Okay. Now, if that's not the case, okay. So see, if I don't do return, then I'll have to write else,
Mm-hmm.
right? Because it's not going to break, right? Or if you say return, then it's going to return. Your insert is going to end here. So
Mm-hmm.
better we give return, right? And in that case, else is not required. Okay, or obviously it means if you are at line number 35, it means that your if has failed. That's why you are at line number 35. If was true, you would have anyway gone with return, isn't it?
Yeah.
So we don't have to say else. Okay, now we need to find out the last one. So I'm going to introduce another pointer called last, and by default in the beginning it should be same as your first self.head. So self.head will remain where it is and last will go on till the last. So while last dot next node. Okay, while last dot next node is not none. Same as what we are doing in traversing. While header is not none, right? So whether this is header is not none. So moving last, not the header. Header will be at the first itself. Okay. So while okay, while okay, now here. What I'm thinking is not none or it is true. Okay.
Mm-hmm.
I think not none should also work, or you can give it a true. Let's see. Okay, not none should also work here. And what I'm going to do is this last will become last dot next node. So last is going to the next node till it is really the last one.
Mm-hmm.
And when you reach the last one, then you say last equal to, in fact, last dot next node equal to your new node.
Yeah.
Correct? And
Yes.
that's it. So last node is now added to the new node. Okay, so first node will remain first. Okay, header is not changed. Last dot node is going to the new node. Let's
Mm-hmm.
check if this is working fine. So to the March, let's add April.
Okay.
So add April at the end. So I'm going to say list dot insert end, and we'll say April. Okay, and now traverse the list, print the list.
I mean, but there's no point of just adding at the end, right? You can just like continuously do it normally then.
No, you can add at the end, right?
No, I'm like, instead of like doing this and adding at the end, we can just like continue on with the list and say N3 is equal to.
M3, okay, so you can say M3 equal to, but how do you link it to the N2? N3 is new value, but how do you link to N2?
Okay, okay.
So no, see, the function we write is anytime you can call it. See,
Mm-hmm.
like after 100 line also, if you want to add, you can call it. Otherwise, this whole logic you have to repeat again.
Yeah.
right? So I don't want to repeat whole logic. It's like you asked me, right? Why don't we have something called append? So when you are done, right? When you have done all the hard work, then
Yeah.
it's simply calling that function. That's it.
Okay.
You don't have to think about the logic again, right? You're simply calling the function and function is doing your job,
Yeah.
right? So yes, I mean, you can manually do the same stuff, but what I'm saying is function is kind of hiding, right? Data hiding.
Mhm.
Okay, it is encapsulation is done. You just need to know insert and your job is done. Okay.
Yeah.
So this is how you can add. Okay. Now the important one. Okay. We need to add in the beginning. Okay. So inserting between, so we'll say inserting between two nodes.
Mhm.
Inserting between two nodes. So inserting between two nodes, yeah, I'm going to use def insert underscore between. Okay, now you see between will need data and also the node to which you want to add. I want to add to E3 or E4 or whatever, right? You
Yeah.
also need to mention the previous node. Add after second node, add after third node. Okay, so
Mhm.
here we will say, say middle node or something, or between node.
Mhm.
Between node, and this is our what I've been using here, new data, right? So we'll say new data. Okay, so new data and between nodes. The first one is node, and then is the value that we need to add. Okay, great. So first thing, we need to create the node. Okay, so we are going to say new node equal to node new data, right? Done. So new node is created. Now we need to check if it is first node, right? Just like we checked there, right?
Mhm.
Okay, so we can check that. And second thing is this between node has to be present, isn't it?
Yeah.
Okay, if between node is not present, then there's no point. I mean, we can't insert it. So let's do one thing. Let's check it before creating a new node. Okay, what's the point of creating new node? Okay, so
Mhm.
let's check. So I'm going to say if between node is none. That means
Mhm.
the between node is not there.
Yeah.
Okay, then we can say print. Okay, the node or between node, the between node is not available.
Mhm.
Okay, that's it. And you can say return to break this function. Or if it is not, then we have to do the hard work. So node equal to new node and next new node dot next node.
Mhm.
Okay, so new node dot next node is going to be the middle node's next value. It should point, so new node next value should point to what is current middle node's next value, isn't it? So you will say between node dot next node, right? So to whichever this between node is pointing, same node this new node has to point.
Okay.
And your
Don't we have to also know the previous node? Do we only need
this
to
is the
know
previous node, right? Between node is the previous node. This is
Okay,
given
okay.
to you,
Okay.
right? This is
Yeah.
given to you. So whatever is the current, node to which this is pointing should be
Mm-hmm.
the same thing the new node should point. And this between node, next node is your new node.
Okay.
Isn't it?
Yeah.
That's it. This is how you have been able to insert in the between.
Okay.
And now let's say here I go and I call in between node. Okay.
Mhm.
Okay. So here I say list dot insert between. Okay. And which node I want to call. Let's say I call N3. N3 is what? March. And now I say here, okay, November.
Mhm.
And when we call this, so N3 was March.
March.
So after N3, November got inserted,
Mhm.
right?
Yes.
So this is how you
Insert in
could,
this.
yeah. Okay.
Okay, sir.
And one more thing is left. That is to remove, correct?
Yeah.
Now let's go back to the whiteboard again. Let's say, okay, I want to remove this.
Okay.
Simple. If I want to remove this, is it first value? If it is first value, simply the header should move here. Header will be here, right? This arrow.
Yeah.
Move this to the next and drop this. Delete this. Don't leave it hanging in the memory. Otherwise,
Yeah.
memory, it will be there in the memory. So delete this. If it is at the end, very simple. Go to n-1, reset it
And
to null, and delete this. So, like for example, if this is like connected and I need to delete this, okay. So you need to reset this one to the null first
Mhm.
and then delete it. If it is something in between, you have to break this link, set this link to this one, and then delete this,
Mhm.
right?
Okay.
So can you try this today? If
Sure.
not, we'll do it tomorrow.
Okay.